So in this particular session, we will be discussing about radical and surd. So this is from grade 10, right? Unit 10, same as that. And then after that, what we'll be talking about in this particular question is that let's talk about simplification, right? So since we have already talked about the same order, and then the radicand should be same in case of addition and multiplication. I mean, in place of addition and subtraction, but in case of multiplication and division, just the order should be same, right? So what we've been given is that we've been given a mixed surd, right? So let's just multiply this. So this is our simplification, okay? So what we do is let's multiply with 5 under root x first of all. So 5 under root x and then 5 under root x plus 3 under root y plus 3 under root y, 5 under root x plus 3 under root y. Okay, so when you multiply, how much will you get? 25x plus 15xy plus 15xy plus 9y. Okay, so your answer will be 25x plus 30 under root xy plus 9y. So this will be your answer. Okay, so when you multiply this, or you could have just done it as a plus b whole square as well. You can do it that way as well. Okay, so this is how you basically solve this sort of question. It's just basic multiplication. Okay, so basically we were able to multiply this surd with this surd because the order was same. Okay, if the order had been different, we could not have multiplied it. Okay, what we need to do in that case, first of all take a LCM, and then after that turn it into same order, then after that multiply. Okay, so what about in this case? So what is happening over here is the order is different, right? So in order to divide, we need to have the same order, right? But this is a pure surd. Remember, like if you open 8 is like 2 cube, right? So that means 2 will be going out. So in this case, if you take a LCM of 16, so 2 8s are, 2 4s are, 2 2s are, right? So that means 2y will be outside, 4, and then your under root x will be inside, right? What about in the bottom one? So what you will have is 2xy. That's the number that you will be getting outside, right? So after that, what you can do is basically cancel out 2 and 2, y and y can be cancelled out. So under root 4x by x. You can write it in this form, or you can change it into same form as well. How can you basically do that? Let's see it as well. So what you can basically do is just add a root and then just add a square to the x. Okay. After that, let's take LCM of 2 and 4. You'll get 1 and 2. You'll get 4 LCM, right? So what you can do is basically this will be your 4x, and in this case you'll have to multiply it by 2, and then your x will be 4, right? So after that, your root will be same, and then x, and then you'll have your x4, right? So that means this will have a power of 1. That means you'll have 4 and then 1 by x cube. This will be your answer. Okay, so you can solve it in this way as well. Okay, just change the thing. If it's a pure surd, change it into mixed surd, and then after that just see the order. If it is not same, take the LCM, and then after that solve it. Okay, so similarly in this case as well, what do we have is x minus y divided by under root x square minus y square. So what's the formula of a square minus b square? It's a plus b, a minus b, right? So similarly, x minus y under root x square minus y square, right? So similarly, as I have done over here, I can put a root in that. So what I can basically say is x minus y square under root, right? So this is also within a root. So I can just write it x plus y, x minus y, right? So since both had the same order, that means now we can just make it into one square root, right? So x minus y square x plus y x minus y. So we can cut this with the 2. So our answer will be under root x minus y x plus y, right? So all I did was basically change this into a root form, and then after that divided it together because the order were same. And then if the order had been different, I would have to do a LCM, and then after that assign the power to that as per the root, and then after that do your computation. Since over here it's not the case, it's pretty easy, right? So that's why we did it in this way. Okay, so this is how we solve this kind of problem. If you have any questions regarding radical and surds, please do comment down below. I'll definitely be happy to answer it for you. Until next